Swayam Prabha. Digital India. Educated India.
So, the caching ability of the routers is actually helpful. It will help you to minimize the latency in the transmission, or the from the end consumer's perspective, the excess latency is actually reduced. So, now that actually translate into a problem which is finding the nearest content store. So, meaning if the original content is actually stored in many different routers caches, and then how do I locate the one of the router having the content, and from which I can actually access the or make the request and borrow the content from that router. So, this actually boils down to three sub problems. One is, you first of all you need to identify the nodes which actually have the content. Node in the sense the routers in the ICN network having the a particular content which is actually required right now, and you make a request to that particular router or the node to bring the content to your own place, to this router, and then forward it to the intended requester in the first place. So, these are the key tasks that we want to win. Now, how exactly this can be done? Because the content itself is identified by names. How do I know as a router, one router knows a particular content exists in the another router's cache? This can be actually achieved by periodically exchanging the control piece of information. So, here in the sense, the control piece of information is the catalog of the data chunks that exist in the different routers. So, whether they have stored the content or not, these routers actually keep exchanging that information at periodic intervals, based on which the other routers will actually know that a particular content exists in the network. And clearly, because the sheer number of the routers that exist in the network as big as the internet, this piece of exchange is actually not scalable. What you can think of the simplest solution is to build a service like the DNS. So, what the DNS does the translation of the domain names to the IP addresses. So, domain names and IP addresses point out to one particular host to which you establish a connection and then make a request for a particular type of the content. Now, what I am referring to here is a service which is taking the name as the request, and then it figures out in the network which are all the routers in the network are having the copy of that content, and then it comes back with an answer. Okay, router R1 has, a router R10 has, a router R1000 has, so you can query any one of them. So, and then the router in question can decide to go either to R1 or R2 and R1000, whatever the router which it thinks as the best location to get the content from, and get the content from that particular router. So, this is again comes with an assumption that the service that I am referring to as a DNS like service is constantly updated with the information, because the routers have a limited amount of the cache with them. So, they can at some point of time they might decide to discard some content, bring some new content and store that for whatever reason. So, the service that I am referring to should have the ability to constantly getting updated itself with the new piece of the information, be it the something getting deleted in some routers, or something new content being stored, new content being generated from some producers, all of that it need to know. So, can we build such a service? In reality, the answer at this point of time is not clear, but this is actually a thought process. That is one issue that we can address with the caching the content. So, the other issue that we wanted to achieve is something with the routing. So we said that routing actually should happen using the names. So we want the ability of the some ability to deliver the content by using the names. That also means that routers understand and do the routing also using the names. So there are two choices for naming the content, which is one is the flat naming convention, the second one is the hierarchical naming convention, and the third one is using some attributes. Which of these actually help the routers? So if you use the flat naming convention, then because there is no structure in the way names are generated, so there is no choice for the routers other than to keep the entire name itself in its routing table and where to go or get the content that particular name. So on the other hand, if you use the hierarchical naming convention, then you bring some structure and then you can aggregate those names and compress them, and to at least to some extent you can reduce the routing table size. So routing tables now contains the names which are looking something like this. So if you want abc.jpeg, then you need to go to router number R2. On the other hand, if you want 123.moe movie, then you need to go to R3, or interface number 2 and interface number 3, something like this. So now how does the router know abc.jpeg is existing in the R2? How does the router know that a new content with the name abc.jpg get generated? And the answer to this is to again the control channel information. Just like the service that we were referring in the previous slide is receiving the content or update from the different sources, the routers also need to keep the updating their own routing tables and keep consulting that service or the any other mechanism that exists which actually brings you updated piece of the information. But what I want is this mechanism, whatever we are using, is robust enough which can actually sustain faults in the network. Sustain the faults in the sense that what if some of the routers actually fail in the network? Can the remaining set of the routers will come together and build the updated piece of the information, routing tables, and can the routers learn the loss of information in the network and stuff like that. And this comes with, as I said, comes with an expense of the data exchange, control data exchange in the network. Can we keep this control information exchange information to a minimal extent? Can I the simplest way is to every router advertising its own routing table containing these names to every other router in the network. So can we, because the routing tables are themselves are quite large, can we keep this information to a minimal level? How do we optimize this data transmission originating from the control channel? And of course, this mechanism also need to be scalable enough, because the larger namespaces coupled with very dense networks with large number of the producers actually put pressure on the routers themselves. Not only in the larger the routing tables you have, larger the time it takes to propagate that information to your neighbors. And since every router is having large routing tables, in order to process that routing table and learn what is existing where itself is going to take lot of time. So how do I build a scalable solution which is workable in a network as big as the internet is the question. We don't know the answers yet, because ICN itself is at a very early stage of its design. So as I said, the naming itself can be of the two types. One is the flat naming convention, and the other one is the hierarchical naming convention. So we said that the hierarchical naming conventions are better for the building the routing tables. So if you use the hierarchical naming convention, then you can do the IP prefix just like the IP prefix agrees. The name prefix can be aggregated. It also brings the helps us to minimize even the control channel data exchange. because once the routing tables are compressed, they are of the smaller size, then it also means that you exchange a smaller piece of information with the other neighbors in the network. On the other hand, if you use the flat naming convention, then so entire routing table need to be shared with your neighbors. Then so it is entire routing table. So routing table itself is quite large. So it also means that a larger number of the messages are required to pass on the routing table to your own neighbors. So these are the two choices that exist. Apparently, the hierarchical mechanism works out to be, at least appears to be better, but we don't know yet whether this can work on a network which is as big as the internet. So that is hierarchical routing table is one aspect, and there are other routing mechanisms that are also possible. So let's do a comparative study of the hierarchical routing mechanism and what are the other routing techniques that we can bring in. So on the left hand side, what you see on this slide is the set of computers or the users, particularly named as A, B, C, D, E, F, and they are divided into two different bunches. So ABC is connected to one of the router. Let's call this router as R1 and this router as R2. And ABC end users are interested in receiving the content which is having the prefix RSDP. On the other hand, DEF users are interested in receiving the content which is having the prefix ES. So if only ABC are interested in the content generated with the prefix RSDF, what I can think of is R1 having a routing table entry with the prefix RSDF, and similarly router R2 having an entry with the prefix ES. So on the other hand, both ABC group and the DEF group itself is interested in receiving the content with the prefix IC, because they are connected in that fashion, and they are also interested in the content generated with the prefix UFF. So I can keep a routing table entry with the prefix IC here and routing table prefix IC here at the router R2. Similarly, I can keep one routing table entry in this router. Let's call this router as R3 with the prefix IC, because all of them are interested in that one. And similarly, I can keep one routing table entry with the prefix UFF in this particular router. So this mechanism of the storage works as long as the producers are directly connected to this. Any producer which is connected to, let's say P1 is producing the content with the prefix RSDP, and if this router R1 knows how to fetch content from that producer, then we are good. And on the other hand, if the producer P1 is existing or connected to this router R4, then all of these intermediate routers themselves also need to have an entry corresponding to RSDP as well, because you need to forward those requests and get the content. So that's how the hierarchical routing table structure is actually built in the network, and not only built, it need to be propagated. So if someone tomorrow, if one of the user on the one group actually wants to access the other content, they need to know how, the routers need to know how to propagate that information and get the content. So that is the hierarchical routing mechanism. The other one is something which is motivated from the peer-to-peer networks that are operating over the IP networks. So these peer-to-peer networks actually use something called as the distributed hash table. So what this distributed hash table is basically a laundry list of all the nodes which are having a content, a particular content type. So for example, if you are interested in the movie let's say movie, and the client number 1, client number 2, so on client number n might be having that content. So for every piece of information, who are all the clients which are actually having that content, that list is built, and this list is constantly updated and they are propagated among the the nodes that exist as part of the peer-to-peer networking structure. So that is how they operate. So you can refer to, you can ask what is the recent distributed hash table, and then referring to that I will figure it out. Okay, this A, B, C now currently have this content. Let me A is nearer to me. Let me query A. If you can't, if A you cannot get the content from A, let me go to B and then query something like that. So dynamically a subset of the users which are part of that network having the content will keep serving the other users in the network. So a routing mechanism which is looking somewhat similar to this one can also be adopted in the information centric networking. So what I mean by that is, if you take the previous example on the left hand side, so I build a distributed hash table for the content which is having the prefix IC. I build a distributed hash table for the prefix ES. I build a distributed hash table for the content having the prefix RSDP, and then I circulate among the nodes which are actually interested in receiving the content for that prefix. So for this network example, RSDP prefix is interested or can be consumed by nodes ABC, and similarly ES is consumed by DEF, and then ABC and DEF, all of them are interested in IC. I circulate these respective hash tables among those particular set of the nodes, and then referring to those hash tables, they can actually make the routing decisions, and from here to get the content that can be dynamically decided. So this is one way of, another way of looking at the routing operation. So the last feature of the ICN network is security. We said that the security in the IP networks is given by establishing a tunnel between the two end hosts, and the plain text data is actually crossing across this tunnel, and we want to exit from that semantics and bring the or attribute the security itself to the data itself. So how do I achieve that kind of the semantics? So of course we need a strong cryptographic semantics or mechanism to bring that notion. So what we want is the name of the content, and the content itself is strongly associated with each other, and somebody cannot change the content name with a different one. Something which is having some content, let's say you have a file with the content ABC, and I have named this as 1.txt. Tomorrow some of the routers should not come and change this name to 2.txt. So even if the router changes, the end consumer should be able to identify that this data is not authentic, which is same as that of generated by some producer which actually originally generated this data. So I can use digital signatures, I can use hashing mechanisms to name the content that we discussed earlier in order to bring this association. And we also need a mechanism for the data origin authentication, meaning that since the data itself is cached across many routers in different caches, so if cached content is served by a router, then the end user should still be able to guaranteedly know that this content itself is same as that of some producer at some point of time. So I need such kind of the authentication mechanism, and I also need a mechanism to identify the or validate the integrity of the content. Something content itself has not been changed. So all of this can be achieved by using some sorts of the cryptographic mechanism, and if you want to additionally give security to the content also by using encryption, I can also do that. So in effect, I want some of the cryptographic mechanism to achieve the security semantics that I want in the information centric networking. Now these are some of the features that we require, and we broadly looked into what are the mechanisms that we can use to achieve those semantics. We wanted a naming mechanism, so we said that we can use the flat naming convention, we can use the hierarchical naming convention, we can use the attributes to name the content, we wanted a caching mechanism. So we said that you can either do a caching locally without cooperation, or you can do a cooperative caching. You can build DNS like services to figure out where exactly the content exists. And I said that we require mechanism to route the request and get the content, and again we can use the external services or the internal routing tables itself to do the or identify the where exactly to forward those requests. And we wanted security, so we said that some cryptographic mechanisms can actually give you the desired security. Now after having all these features, so now let's look at the problem from the communication paradigm from a different perspective. So if I have assuming all of these abilities I have in the ICN network and I am able to use that, what is the implication of such a communication infrastructure on the current can we compare that distribution to the current IP network? There is something called access control mechanism and authorization mechanism that exist in the current IP network. The producer can control who can actually consume the content. So for example, if some content is sensitive, for example, if I take the case of the some data generated in the military setup, or some data which is can be consumed by only some paid users. So such content need to be protected, and you can enforce the access control mechanism, and the producer, since the server has the details of who is making the request, and he can actually, the server can actually verify and then authorize a particular user to whether he is allowed to use the access or not allowed to access the content. But in the ICN networks, what we are talking is a network having the ability to cache the content. If one time the content is actually retrieved from the producer lose that control of enforcing the access control mechanism. So now the pieces of information exist all across the network in different routers, caches, and how do I as a content producer actually enforce this access control mechanism? So this is in a sense, since at least looking at the current usage perspective, this ability of the access control is actually required. Now this can be broadly addressed in two different ways. One is you bring a separate entity in the network whose principal job is to authenticate a particular user and authorize whether he is able to access, he should be allowed to access the content or not. So what I am talking is, there are some routers who are internally connected in some fashion, and there are some consumers who are interested in some content. There are some producers which are generating the content and supplying to different users through these intermediate routers. And what I am referring to is, so there is one service, maybe a service which is similar to that of the DNS, which actually keeps track of who is producing what content, and the same content is actually stored across many different routers. And when a particular user makes a request, the router first query this service whether that particular is allowed to access that content or not. So if he is allowed to, if the service actually says that he should be allowed to access that content, then the router will forward the request to the wherever the content is available, pass that content, then forward it to the client. And this comes with the implicit assumption that this service is trusted. He is not selectively manipulating the some users. He is not selectively deciding to permit some users and not selectively deliberately denying some users from accessing the legitimate content. So, and also it comes with the assumption that implicit assumption that wherever the content gets cached in the network, this service is able to keep track of all those changes that are happening dynamically in the network. So that is one way of looking at the or bringing the notion of the access control and authorization. The other way to look at or address this problem is to look, it is the you cache the routers not only cache the content, but also keep a list of who are the users who are actually can access that particular content. So I have a content 1.jpeg, and then what I have is I have a list of consumers C1, C2, C3, so on. Cn are the users who are allowed to access this content. Similarly, if I have 2.jpeg, and then another set of the users, maybe C3, C4, C5, are allowed to use that or access that content. So every piece of information that I have stored in every router has got this list of or laundry list of the who are the users who are actually authorized to access that content. Now this is obvious that this will put further load on the network routers. Now I not only have to store the content, but also a laundry list of large number of the users who are actually authorized to access that content. Now how do I build such a solution which is scalable, which can work on a network as big as the internet is a question, but nevertheless this is actually one way of looking at the problem. So we don't know whether this will work on a larger scale or not, but one of the approach you can think of. So having understood all these problems and different mechanisms that we can actually use in the ICN network, so let's now turn around the table and then look at what are the ICN is a nice feature to have, but what are the unique challenges that the ICN brings onto the table. So one of the challenge that we did, the source lose track of who are all the routers who are actually having the copy of the same content that is produced by itself. So whether let's assume for some point of time, if the producer wants to discard that content, it is no longer relevant. So how do I know that as a producer all the copies that exist in the different routers caches are all erased? Whether someone is still keeping the copy of that content, and how do I make sure that all the copies are erased? I really don't know. So in a sense, what the source, the data producer has the ability to enforce the when to serve the content, how long the content, what is the lifetime of the content, who caches it, and who are allowed to access it. All that information control is actually lost in the network. But indeed this kind of the mechanism is required at least in today's context. So for example, some of the YouTube channels, based on the number of the users who watch that video content, the billing is done. How much revenue that the content generator would get is based on the number of the users. If the source itself loses that control, in this case the Google itself loses the control over how many number of the consumers actually consume this content, because the content itself is cached among many routers, and they, without telling the source, actually distributed the content. Now I don't have any mechanism to find out what is the basis on which I am going to share the revenue, or I am going to generate the revenue for a particular content producer. So we don't know the answer yet. How do I bring this notion into the ICN paradigm? But that is one of the challenge we want to address. And the second thing is, we said that the ICN paradigm protects the end consumers from receiving the unwanted, not receiving the unwanted content. So nobody can actually send a content to your door unless you made a request in the previous case. Only what I request I will get back from the network if it exists. So it is as simple as that. But that comes with the expense that the routers will keep the routing table entries with the names. So as we said that routing tables keep the names, and the routing tables are many orders bigger than that you see in the IP networks. So now the question, what if a malicious user which is part of the network bombards the network with too many number of the stale names? I have this copy of the name data, this copy with this name and this name. So many, you can artificially create 1 million names and then bombard the network, and by virtue of that, the routing table sizes across the routers can grow substantially, and then that itself can become the burden. So it can become the victim of the denial of service attack. So constantly they might keep updating the routing table, and then eventually the routing tables grow to such an extent, then you may not be able to fit them in the available space. So that is another danger that comes with the ICN networking paradigm. So we don't know how this can be addressed, but nevertheless that is the another challenge that ICN networks actually bring in. And another challenge the IC network brings is, so when the content is produced, the content will be named with some name, and another service or an entity which is oblivious to the producer can actually change the name of the content. So for example, whatever is NDN for the producers might be renamed at a subsequent point of time to bring some structure to the naming, to something like IITA./course/NDN. If the consumer does not understand this renaming mechanism, then he may not be able to get the content. How do we actually make sure that all the consumers actually are made aware of this renaming that has happened in the network? So again, how do I communicate that piece of information? We don't know yet. And the last challenge the ICN network bring is something called as the mobility management. So mobility management, we know how the mobility is handled in the IP networks. So for example, if I am walking and at the same time I am downloading some content on my device, maybe a mobile or the laptop or any other device. So I might be connected to one base station, and as I move, I might go and connect it to the another base station, and then I want to, when I make a handover, I re-establishes another connection to the same server and then get the content. Now, if the same user is actually walking or moving in the ICN paradigm, how does that look like? So I might be connected to the consumer 1 is connected to the router R1, and as he moves, he might be still connected to one chance that he might be still connected to the R1 itself, or he might be connected to another router R2. So if he is connected to the same router R1, not necessarily on the same interface as that previously, but on a different interface, he might be making the request. That is still okay. So as long as I know who is the client, and on some interface, if not on interface number 1, on interface number 2, the requests are coming, I can still handle that. So if you move from the router 1 to R1 to R2, so I can still make that request instead of R1 to R2, and R2 can figure out how to get that content and still serve you. So from a consumer's mobility perspective, the handling the request when he is on the move is actually more or less it can be handled fairly well. But what if the source, the content producers himself or herself is actually is on the move? Somebody is doing a video audio conferencing, and then he is actually moving, sitting inside a vehicle, he is doing the video conference. Then the routers need to be dynamically made aware that he is now connected to, not instead of R10 he is connected to R20. You need to make the next request should go to content request should go to the R20 instead of the R1. How do I make the routers in the network dynamically aware about the mobility of the producers is the another challenge. Again, we don't have the concrete mechanisms to address this yet, but nevertheless that is one challenge the ICN network actually brings. So these are some of the issues that the ICN networks actually bring onto the table. There are some features that we want in the ICN network, and that has got the advantage. And there are some challenges that the ICN networks brings, and that we need to address. So there is no clear answers. Different research projects have attempted different mechanisms to address these challenges and provide the features that are required in the ICN network. We will take few examples of the ICN network architecture to understand how these features and the challenges are addressed in those architectures. So, that is the discussion for the subsequent lectures. Thank you.